Good afternoon, students. Today, I'm going to take this first unit topic again repeated. Uh, the new topic is going from random noise, Gaussian Markov random field, and standard deviation field, and also linear and nonlinear operations. Now we'll move to the topic of random fields. Today, the sample random fields already, sampling and quantization study for digital image processing, digitizing work. In physical sampling environment, the random noise is always present in the image. So, the random noise is important to consider what does it say this here sampling theory for random fields. A continuous stationary random field f of x comma y is called a band limited if its power spectral density function s of epsilon 1 comma epsilon 2 is a band limiter. That is if s of epsilon 1 comma epsilon 2 equal to 0, if the condition is for cardinality or norms of epsilon 1 greater than epsilon x0 comma norms of epsilon 2 is always greater than epsilon y0. In the sampling theorem for random fields, if f of x comma y is a stationary band limited random field, then it will be denoted from the type of f complement of x comma y equal to delta or equal to sigma m and n equal to minus infinity to plus infinity. That is f of m delta x comma n delta y. If this is say sine of c of x epsilon of x xs minus m, sine c of y epsilon ys minus n converges to f of x comma y is a mean square sense. That is e of norms of f of x comma y minus f cap of x comma y whole square equal to 0, where epsilon xx equal to 1 divided by delta x comma epsilon yx equal to 1 divided by delta y, and epsilon xx is always greater than 2 epsilon x0 comma epsilon y is always greater than 2 epsilon y0. So remove that the random field. How to this say this fine tune from the theorem to state this random field f of x comma y is may sample above this n state. In this say this continuous random field of f of f cap x comma y can be reconstructed from the sampled sequence such as f complement of convergence to f in the mean square sense. So in this it can be shown that there is a power spectral density function s of s and epsilon 1 comma epsilon 2 of the sample image, and f of s x comma y is the periodic extension of s epsilon 1 comma epsilon 2 is given by this equation. Ss of epsilon 1 comma epsilon 2 equal to epsilon xs and epsilon ys equal to sigma sigma k l equal to minus infinity to plus infinity s of epsilon 1 minus k epsilon sx and epsilon 2 minus l epsilon yx. So here this image reconsidered by this ideal low pass filter, we will gain 1 divided by epsilon xx and epsilon yx. So reconsidering this image power spectral density is given by this that equation. Again s of cap complement epsilon 1 comma epsilon 2 equal to sigma sigma k l equal to minus infinity to plus infinity s of epsilon 1 minus k epsilon xx and comma epsilon 2 minus l epsilon yx with the weighted of w, that is the reconstruction from that image epsilon 1 comma epsilon 2. That will be equivalent to that is s is s of epsilon 1 comma epsilon 2, whether w of epsilon 1 and epsilon 2 equal to 1 or 0. That 1 is the condition epsilon 1 comma epsilon 2 belongs to that real number, 0 is the otherwise. So the aliasing that is the power, and the standard deviations is a square is the power is tail in the power spectral of this outside of R. So that is sigma, that is a square means variance of A equal to integral double integral epsilon 1 comma epsilon 2 not belong to real number. That is you come to S of epsilon 1 comma epsilon 2 d epsilon 1 d epsilon 2 equal to whether this is conditions of applicable from integral minus infinity to plus infinity 1 minus w of epsilon 1 comma epsilon 2 of S epsilon 1 comma epsilon 2 d of epsilon 1 and d of epsilon 2. So in this say this consideration of this which is 0 if f of x comma y is a bandwidth with epsilon x of 0 less than or equal to epsilon sx divided by 2. So epsilon y0 less than or equal to epsilon yx divided by 2. This analysis also be useful to bandwidth image containing wideband noise is sampled. Then the signal to noise ratio of the sampled image can determinate significantly unless it is a low pass filter before the sampling. So here consider from any type of random noise or random field and sigma field will be based on this the low pass filter before this sampling one. This is internal slicing of the spectrum for sampling. So here this extension sampling theory will come to increased sampling intervals. Depends upon this the type of this value. This is another type of hexagonal sampling, optimal sampling. It depends upon this equation to become to change over from the type of minimum random sampling of this random fields will come to construction from the type of informations. The next concept we move to again it will be reconsidered from the type of this image come under this matrix format. Yesterday we discussed about this book Gonzalez and previous the random noise and random field we studied from fundamental of digital processing in this AKJ book. So in this concept from yesterday we studied about this pixel relationship among these basic fundamentals. So continuation about this linear versus non-linear. Based on this, the type of the information among the mathematical tools used in this digital image processing. So element-wise versus matrix operations. The element-wise operations will come to say this is a type of pixel by pixel basis. We mentioned earlier this is say the type of matrix theory will be 2 by 2 matrices. We will come to the examples of will be consideration from A11, A12 and A21 and A22 and B11 and B22, 12 and B21 and B22. So it will be say this any type of element wise product. The type of this product symbols will become to dot circle and then cross or to circle. These are two the images will come to protection of this element wise product. So in this say this the two matrices will come to multiplication by the type of the information A11 B11 A12 B12 and then A21 and B21 and A22 and B22. That is the result of the product of this value. Again the type of matrix multiplication concept will come to say here A11 B11 row and column will come to multiplication in this factor of first element. So first element A11 A11 into B11 plus A12 into B21. So it will be the multiplication. Again this A21 B11 and A22 into B21. Again same this is a reconstruction from the type of this element from next element here A11 B12 plus A12 B22. Again A21 into B12 and A22 into B22. So there is this cross multiplication of this matrix product. This will come to an element, will come to element wise addition and subtraction. So based on this notational, we classically will come to say this linear versus non-linear operations. So one of the most important classification of the image processing method is whether it is linear or non-linear. We will consider what are the operations will be general operations of this say here the type of h, that is the product of output of image of g of x comma y, that given this input is the amplitude function of f of x comma y. So h of f of x comma y is the resultant value is g of x comma y. So there are two arbitrary constants on the a and b. In this image is arbitrary image is f1 of x comma y and f2 of x comma y. H is set to this linear operator. We come to this h a f1 of x comma y plus b f2 of x comma y equal to a h of f1 of x comma y plus b h of f2 of x comma y. So equal to g a g1 of x comma y plus b g2 of x comma y. In this equation to be indicated there is output of linear operation to be applied the sum of these two inputs the same as performing from operations individually on the inputs and summing the results. So in this basic fundamental of production of two inputs, the summing of the results or addition, and that is a linear operation by on the constant multiplied by this input in the same. As the output of this operation due to this original input, the multiplied by this constant. So that is called first property of this value is called additivity. The second is called as homogeneity. So by definition of the operation to fail is the equation said to be this non-linear. As examples of suppose that is h is the sum of operator, sigma is sigma. The function performed by the operator is simply to sum its inputs. So that is a tested linearity. We start with the left side, that equation will be proposed from this right side. Here this is sigma a f1 of x comma y plus b f2 of x comma y. Here we equal to sigma a f1 of x comma y plus sigma b of f2 of x comma y. The constant terms will be outside of this summation symbol. And finally we got this a of g1 of x comma y plus b of g2 of x comma y. So here this is the fact of summation is a distributive law. You come to application about this the particular sum operator is a linear. So in this other hand, suppose we are working as a maximum operation, whose a function to find the maximum value in the pixels on is an array. For our purpose here, the simplest way to prove the operator is non-linear is to find these examples of to fail this equation from the below equation 2.23. Consider the following two images: f1 equal to 0, 2 and 2, 3 and f2 is 5, 4, 7. We let it will be assumed that a equal to 1, b equal to -1. The test linearity of the start with this left hand side equation. So here this is a maximum of 1 of 0, 2, 2 and 3 plus -1, 6, 5, 4, 7. So automatically we adding this value -6, so -3 and -2 and -4. Here this will be working, it will be similarity, we will come to consider about this right hand side. We will say that the 1 of maximum of 0, 2 and 2, 3 -1 of maximum of 6, 5, 4, 7. So that is the value will be equal to will be considered from 3 plus of -1 of 7. So equal to you will say this is a -4. So in this say that the symbol will come to say the type of this information is 3. Here minus symbol is there, so minus this maximum is 7. So automatically say -4 the equation. Here -2 with this value of proposing the term of this equation. So linear versus non-linear. So here it says each and every max operator is a non-linear operator. So arithmetic operation is also be performing in this type of linear and non-linear application. That is the example of summation, addition, subtraction, multiplication and division. In this operation we will come to this section, we will come to analyzation from the different type of image. Suppose using this addition, the averaging of noise reduction come to, especially we come to heat of x comma y, that's a noiseless image of f of x comma y. So here g of x comma y equal to f of x comma y plus heat of x comma y, that is the specification of this output image. In this say that the noise will come to satisfied from this construction, just satisfied from this image of g cap of x comma y. So that is this arithmetic application come to say the type of this value, come to different type of this variance value, come to production from that standard deviation value. Finally, the square root of variance of this standard deviation, the function sigma g of cap of x comma y equal to 1 divided by square root of k of sigma eta of x comma y. So in this value will come to each and every time the k value to be increases, that is the variability. That is this standard deviation of the value of each location to be decreases. So in this approaches will come to be registered from this output and the input or to avoiding this blurring and otherwise artifacts in this output. So most of the applications to averaging the fields of astronomy where imaging under this very low light levels often causes sensor of the noise to render individual images virtually. That is useless for unless the type of information from lowering the temperature of the sensor helps to be reduce the noise. So in this case, each and every time that is a galaxy pair NGC image, we say there's a noise corruption among this particular Gaussian noise. So zero with a zero means and a standard deviation of 64 intensity level. These images, which representative of the noisy astronomical images taken under this low light conditions, is used as all the practical purposes to in this figure we come to specify from this is say the image galaxy of NGC 3314 corrupted by this additive Gaussian noise. So in this say this comparing from the type of any type of images like that here, comparing images using subtractions. So here there is a difference between the subtractions of this resultant image. Another digital subtractions of angiography, the mask image, the live image, difference between and this one. Here come to enhance difference image. Figures A and B, course of this image, Science Institute, Universal Medical Center, Utrecht, that is another ranch. Will come to say the specific boards is a particular image multiplication and a division for sharing, correction for masking. So most of the examples will come to say this. This is here they say arithmetic operations, more this sharing correction, the estimated of the sharing to be the pattern to be corrected. Here they say this reciprocal of a B, and there's a C is come to this say here there's a resultant pictures. So region of interest, the mask to be isolation of teach with the fillings. So here this is set and the logical operations also with the basic operations will come to along with the type of needed to be changed over from the type of intersection or union and some type of set values. So here there is a description about this particular expression value. So operation between this sample space and the null set. Union and intersection with the null and the sample spaces, union with the intersection and the intersection of the set with itself, union and intersection of the set with the complement. So here they say the type of this commutative law, associate law, distributive law, and a demarkant law. Here we say some type of information. Most examples the usefulness of Venn diagram for providing equivalence between the between set relationship. So these are the fundamental concepts among this particular A, B, C, D, E, F, G, H. So here they say this arithmetic and operation, all the operations, the first is ohm symbol, another A complement, A minus B, B complement, and A intersection B, and A intersection B C, and then A intersection B union C. So that's the combination of that particular Venn diagram. The more appropriate of this subset of operations in this table. So in the illustrations operations involving the grayscale image, it came to approaches from complement among this particular pictures. Set operations involve the grayscale images. Original image will come to this say the type of information from A union A, and Cartesian product of for x of product of y, that is especially if we come to design over to Cartesian product, and the relations are more precisely binary relations, especially come to say the binary relation that is Cartesian product A product of A binary relations between the two sets A and B is a subset of A Cartesian product of B. So a pair partial order on a set S is the relation of R, and in such cases will come to say this is a reflexive is one of the property, and the transitive and anti-symmetric. A reflexive means for any A belong to S, and always the resonant value is A or A. The transitive means A, comma B, comma C is belong to S, and A or B, and B or C implies that A or C. So anti-symmetric for this same condition, but A, comma B belong to S, and A or B and B or A, to implies that is A equal to B. So if we consider from that type of operation, linear, logical operation, and or not, it came similar to the illustration of this logical operation to involve the foreground of a pixel black representation from binary zeros and then white binary ones. So dashed lines will be shown from this only reference only. They are not part of the research. So another cases will come to spatial operations is the neighboring operations. So each and every operations to performing here to analyzation from the different type of neighborhood processing is there, especially the type of a nearby neighbor to be dominated from the particular image. Geometric transformations, especially that come to this coordinates, the intensity interpolation of this assign the intensity the value to be to the spatial transform itself. The transforms will come to say this expression from x dash and y dash equal to t, x and y equal to t11 and t21 and t12 and t22 is x y. That is the class of the each and every Excel set. So come understanding about this matrices format, how to say the scale, rotate and translate. That depends upon this the type of three important transformation techniques among this. Any type of matrices is scale, rotate and translate. Sheet in this image. This is the transformation name. Affine transformation based on this the type of affine matrix, and the coordinate and the equals. Here this is an example of T is identity is based on this affine matrix here. The scalings of the reflection of this value come to say this scaling increasing or decreasing. Rotation to angle of this depends upon this value. So that is this information will come to analyzation from the each and every transformation technique to shear and vertical and horizontal. So the intensity interpolation is a very important role. Will come to analyzation from the type of recognition. So in this chapter we say that there are two information to be come to learning here: random noise, Gaussian Markov random field, and then sigma standard field, and then linear and non-linear operation. Thank you. Welcome students. Again, if we say this the type of information regarding from this image representations, here this is some type of stochastic models image representation. If we say so many type of stochastic representation images we consider from the different type of autoregressive AR models. So many image models are there. Especially they say casual models or non-casual models or semi-casual models. So many models of images are there. We'll come to say study about this random field. Last topic, we'll come to say this repetition among this particular individual image. So covariant model. In this say here, the type of many applications such of image restoration and data compression, it is often sufficient to characterize an ensampling of image, but its mean and covariance functions. Often one start with a stationary random field representation where the mean is held constant and the covariance function is represented by the separable or the non-separable exponential models define the sections. Okay, we will study about this. What is say this a separable covariant model? In this case, is a very convenient for analysis of image processing algorithm, and it's also yields this computationally attractive algorithm. For example, algorithm that can be implemented by line and then column by column. It will be already step by step information or logical steps. That is called algorithm. On this other hand, the non-separable covariance function is this better model, but is this not convenient for analysis? So non-separable covariant function is a very much more better. All the computationally attractive algorithms should be there. So covariance model have been found useful to be transform the image coding, where the covariance of this function is used to determine this variance of the transformation coefficient, like that translate, that is mean translation, scaling and rotation. The type of operation will come to performing from transformation. Auto correlation models with spatially the varying of mean and variance, but spatially invariant correlations have been found useful to adaptive block by block processing techniques in image coding and restoration problems. So linear system model, it will say the study of a linear system model from stochastic model used in this image processing method. They say here stochastic model used in this image processing, the covariance model, we say separable exponential terms and a non-separable exponential term. One dimensional only the model says auto-regressive and auto-regressive moving average, ARMA model, the state variables and a non-casual minimum variance. But especially we say this two-dimensional model with the three part of this case of image processing: casual, semi-casual and a non-casual. So in this say here that is image will come to study about this casual and semi-casual and non-casual. In this is two-dimensional performances. In the say study about this is one dimensional, say this casual model says a one row or one column. To specifically to be listed in this inter column or inter row dependencies will be ignored in this only linear system. This model will come to say the type of stable. You will come to study about this the type of S of Z equal to H of Z, and S is epsilon of Z and H of Z of minus 1, power minus 1. So in this support must be lies inside of this unit of the circle. Auto-regressive AR model already told about the zero mean random sequence UN. We will say the type of the auto-regressive process of this figures will come to the output of the system. Here P of the order of AR model. Say AR sequence will be realized from that input of this value and then processing of sigma of the value and then finally output in this side. That is the prediction error filter, the input and then output of this process. This is one dimensional model from auto-regressive model properties. In this is the minimum variance representation in MVR. Come to say here any type of information be like that the casual filter to be analyzation from the type of minimum variance. The casual filter will be defined from this equation AP of z equal to delta or equal to 1 minus sigma n equal to 1 to power p a of n z of z power minus n. So it's called prediction error filter. In this prediction filter sequence of white, you will come to analyze it from the different equations to representation from h of z and s of z. Finally, this is autoregressive model can be modified in this format. So identification of AR models that will be multiplied from both value of this 6.3 of A and 6.3 of B of equation 6.7. Finally, got this the identification of both multiplication of this both sides. So normal equation we come to say this is a representation about this the particular value. So maximum entropy extension is also be applicable from the type of AR models. And finally got this applications of this similar of AR models in the image processing. We'll come to say the representation of image scanning lines. Will come to say this the type of information from data compression and images of the signals. In this regressive representation of this image, will come to n column of un unitary transformation from that is signal of sigma that is v of n of 0 and up to that is the level of different type of AR models. Finally got this un that is the final result. The AR sequence will come to specially will come to specify from the different type of applications. KL transformation to be ensampling Cornell love form, Cornell love transformation. In this equation, in this form, you come to some type of sigma value is used from the type of image column to representation from uncorrelated from the type of this value. The moving average MEA to be representation from the type of uncorrelated random variables to specify from that is a MEA format. The autoregressive moving average ARMA representation, there are different type of yielding of representations of sequence to present over to the type of pictures figure 6.5. So h of z and s of z will come to a representation from the state variables models. Like that will be specification among the sequence yn. The form will come to xn plus 1 equal to an xn plus bn and epsilon n. So it can be representation from this elements of this value of the state variable models. You will say the type of this information come under this image scanning models. So you will say all the type of ARMA models and a one-dimensional spectral factorization. In this case of h of z and s of z. So in this two-dimensional format, you will move to the type of casual and semi-casual and non-casual. We will come to say the different type of AR model method is there. Yeah. The type of information among that ARMA model shall come to representation from Levinson regressions. In this equation, will come to specification among this AR1. Non-casual representation, casual prediction in this case of AR model, the motivation by this factor that the scanning process order in this image pixels in the time sequence. Each and every timeline you will come to sequentially to scanning from this information of this each and every intensity level of this image each and every image. Thus this image representation spatial information have no causality associated in those coordinates that are representation from x and y. It is therefore the think of predictions of process that do not impose the causality constraints that is called a non-causal predictors. So a linear non-causal predictors will become to specific denotation from u complement of n. So depends upon this post as as well as come to this feature value of u of n in the form of u cap n equal to sigma k not equal to n and alpha of k u n minus 1, u of n minus k. So in this case of moving variation amount is to say here MBR system, the type of any type of casual or non-casual MBR predictions really factors. So here this non-casual random variables will come to say the type of study about this non-casual MBRs. So here this is a non-casual moving average of this value of MVRs, that is autoregressive sequences. We will come to specify from non-casual result. Yeah, fast Carnot love transformation is the foregoing non-casual MVR is giving this interesting result to be produced. This formula we are using from the type of this equation shapes KL transformations. So many cases that is the type of transformation from this sinusoidal family, the orthogonal transformation to be discussed in this concept from non-casual orthogonal decomposition of this first order AR sequence method, autoregressive concepts, non-casual model. So in this linear predictions, already told about the type of 2D, the different three important concepts we come to study about here, the three 2D. What is the three canonical forms will come to this 2D model, symmetric process model, like that's casual, semi-casual and non-casual. Like that's the framework to come to linear prediction. There is a types of this stochastic model have to be application. There's many image processing problems. For example, casual models yield regressive algorithm in this data compression of images by the differential pulse code modulation (DPCM) techniques, and in regressive filters of images. Semi-casual models or casual is one of the one-dimensional and non-casual in this other and you will come to this say here the lead from themselves naturally to hybrid of this any type of algorithms. This case 1D and 2D. So the non-casual models to be rise of this transformation based on this algorithm. I will come to say the type of KL transformation like that is say here Markov sequences will come to applicable from the type of filter. So Markov random fit. In this case, this is a type of linear predictions or model to be considered from this effectively from 2D spectral factorization and the spectral estimation will be considered in this section. Sir. We come to say this is the predicted coefficient of that value of this each and every prediction region. We will come to analysis from scanning. Casual means we will come to say x equal to 1. Semi-casual to be intermediate at x equal to 2 and a non-casual or non-casual is x equal to 3. Hypothetical scanning will come to mechanism, we can scan sequentially from top to bottom and left to right. So three predicted regions are defined as follows. Casual prediction. Casual predictor is the functions of only the elements that arrives before it. Thus the casual prediction the region is a figure. You will come to this say here S1 of cap equal to L and greater than or equal to 1, and for every k the union of L equal to 0 and k is always greater than or equal to 1. Where definition of causality to be a causality to include the special cases of single quadrant of causal predictor. Strongly causal predictor basing from the type of this equation. In this say here k non-symmetrical of plane model from causal model only to be representation from. This is say S1 of cap, it's a casual model to representation of W1 cap. Here say this the type of this semi-casual S2 of cap and a non-casual to be surrounding from this all the information S3 of cap. You say this K is the upper direction all the things here say M and N to be representation from that particular value. Always it will be L is the left right hand side. Here say this M and N the same casual and semi-casual, but non-casual will come to no M and L and especially within this M and L. of a origin based concept. Origin based concept 0 comma 0. If the origin is outside, your origin is nearby, but the origin is inside. This is a casual, semi-casual, and a non-casual. The non-casual is a centralized origin. That is semi-casual is the nearby, nearest, inside or nearest of this region, but casual is outside of this region of this point. So this is a canonical forms will come to prediction of this each and every region already clearly known from the two-dimensional array format. How to this pixel to be present over to both canonical form of a casual, semi-casual, and a non-casual format. Semi-casual predictor casual is one of the coordinates, and non-casual is the other. For example, semi-casual predictor is the region, that is casual is this n, and non-casual is m. So if we come to specific from the type of semi-casual predictor. Non-casual predictors say here, say function of the possibly, you will come to the variable of random field except u of m comma n. Then non-casual prediction region is S3 of cap. So especially it will be known from the type of casual, semi-casual, and non-casual. We know from that commonly using from that the type of this window representation from W1, W2, W3. That depends upon this defined from the type of this value. The example, the following are example of casual, semi-casual, non-casual predictor. So it will be applicable from the type of value. So minimum variance prediction MVP will come to analyzation from all the cases, casual, semi-casual, non-casual value. For here they say the type of the value to become to analysis from the semi-casual predictor, non-casual predictor. Stochastic representation from for random field to specify from the type of minimum variance representation, a white noise driven representation, and auto-regressing moving armor representation. So these are the three interesting representation. To among these the three different type of image models: casual, semi-casual, and non-casual. Thank you. Again, good afternoon, students. Today is last topic of Unit 1. Already we study about this image fundamentals, and then what is image processing models, and then now we'll move to color models. Today this topic to be covered from color fundamentals, color models, pseudo-color image processing, full color image processing model, and the color transformation, and the noise in color images. Let us go to this information among this particular color image processing models. Color image processing. So all will be known from color. First of all, color is a powerful descriptor that is often simplifies object identification and extraction from the any real-time scene. Correct. Second is human can discern thousands of color shades to compare to only about two dozen shades of gray. So it will be like that. The type of color image processing is divided into two major areas: pseudo and full color image processing. In assigning from the particular, we say this grayscale intensity or range or intensity. The second images will become to typically to full color sensor. Will come to like that. Will become to digital camera or color sensor, color scanner. If we say the type of information among this image, come to study about this color fundamentals. So in here, all are we know from human brain is the perceived and interpreting color is a physio-psychological phenomenon. Is not the fully understood. The physical is a nature of color can be expressed on this formal basis of supported by experimental and theoretical research. All of you know from this a real-time scenario. So in time to come to the color, especially in the year 1666, Sir Isaac Newton discovered that when a beam of sunlight passes through this glass prism, identification of this emerging light is not the white, but consider instead of this continuous spectrum of color ranging from violet at one end to red is the another end. VibGR. Already we say this rainbow color. VibGR. What does it say? This six brand region. Will say the type of information will come to analyzation from the type of violet, blue, green, yellow, orange, and red. So in this case, no color in the spectrum ends abruptly. That is rather than the color bends smoothly into this next. So normally in this electromagnetic spectrum, the human will be known from this visible length of shadows. It come to 500 to 570 nanometers range. So white observing of the most energy of this other wavelength. So here this so many categorization to be central of the science of the color, light of achromatic, the void of color. So if the some type of attribute is called as say intensity or amount of this or value of this color. The achromatic light is say this is a movie films made by this India 1930s, and also this, so many numerous times will come to say the term of gray or intensity levels, and scalar measures will come to measuring from the type of this black and white or ray grays, and black to gray, and finally gray to white. The chromatic light will spans from approximately 400 to 700 nanometers. So many type of sources, amount of sources like that, chromatic light sources, radiance and luminance and brightness. So radiance is the total amount of energy that is the flow of this light source, usually to measure the watts W. And the luminance is a measure in the luminance LM is a measure of amount of energy that is observed perceives from the light source. For example, light emitted from the source of operating of the far infrared region of the spectrum could have significant energy is the radiance. So in this count to be observed, the perceived the luminance could be almost zero. Finally, brightness is a subjective descriptor that is practically impossible to measure brightness. Embodies the achromatic notations of intensity. The key factors is to be described with the color sensation. So that is important. The three things will become to the major quantities to be analyzation from light source, radiance, luminance, and brightness. So here this is a correct color spectrum to process in their white light through optical prism, infrared to ultraviolet. So this is a wavelength of this comparison from visible range to 4,400 nanometer to 700 nanometers, the wavelength of nanometers. So this is ultraviolet, this is X-rays and gamma rays. Here this are microwaves, then the infrared up to radio waves come to infrared. So approximately there is a notation from that say this colors will come to human eye. So absorption of characteristics of this see the eyes will come to variable combination. The primary color we say is the red, or the notation is R, green is the notation is G, and blue is the notation is B. The purpose of standardization, CIE, the Commission internationally, they Lagrange, the International Commission of Illumination. Illumination Lagrange is the illumination of French term or CIE for standardization. So designed in the year 1931, the following specific wavelength value of the three primary colors. Blue is the 435.8 nanometer range, green is the 546.1 nanometer range, and red is the 700 nanometer range. You come to standard, we set this result such as those figure of wavelength will come to this electromagnetic wavelength will come to this comparable of this electromagnetic spectrums. So this is becomes available for 1965. That's the CAE already known as the Commission for International Technology. Will come to say this standard phone correspond only these figures in the year 1965. Will come to standardization of the wavelength. It will say this the type of diagram. Will say blue and then green to be crosses, and the red is also crosses with the blue and the green also, and then a green is also crosses with the blue and the red also. So you see the depends of on the different type of name of the color is called it here. Blue, red, green. Here this is bluish purple, bluish purplish blue, blue, and blue green, green, yellowish green, yellow orange, and reddish orange and red. You see the different name red will be combination of this uh, blue, green and red. You say that the type of wavelength will come to say that the type of secondary colors we know analyzation from light. Magenta is the red plus blue, the combination of red plus blue with the magenta, and the cyan is the green plus blue is the cyan, and the yellow is the red plus green. So here they say the type of this combination of this diagram here say the cyan, magenta, yellow, the type of informations among this particular informations. So here, what is this primary colors? Here is a primary color, red, green, blue. The combination of red and green is a yellow. Blue is green is called cyan, and red and blue is called magenta. The middle color is a white color. The mixture of light to additive, primitive. And again, this mixture of pigments, we will say this subtractive primitive. This is a secondary color. It's the same magenta, yellow, and cyan. A combination of cyan and yellow is green. Combination of magenta and yellow is red. Combination of magenta and cyan is blue. So primary and secondary color of light and pigment. We'll come to this force with the lighting division. So if you say red energy, it's so many TV camera will come to say analyzation from green and the blue photo. Uh, Phosphor dots will come to say analyzation from additive, primitive, and subtractive primitive cell. Cathode ray tube, which you displayed this year starting in the year 1980s. A flat panel of digital technology, it's a liquid crystal display LCDs, and also the fundamentals different from CRTs to technologies to come to move from this red to green blue. They are required from color pixels or LCD properties. Equidistributional display the properties of polarize the light to block or pass the light through this LCD. And another technology from matrix display technology is a thin film technology, thin film transistor, TFTs. Also provide the proper signal to addresses for each pixel on the screen from that type of this important. Today's LED, lighting emitting diode, and so many saturation from this colors from different plasma TVs. So in this say this say another characteristics among this color. In this say the brightness, it will say the hue and then saturation. So in this section, brightness embodies of achromatic notation already told about this in this previous section. Intensity, and then hue is this attribute to association with this dominator of the wavelength in the mixture of light waves to represent from dominated of the colors perceived by this observer. So in this saturation, will come to this say that combinations among this white and light to mixture of this hue. The spectrum of the fully saturated colors such as the pink or red and white, lavender is the violet and white, and less saturated with this degree of saturation from proportional to this amount of white light added. In this chromaticity, you come to say the type of is called Tricimulus values and then denoted from x, y, and z respectively. A color is that is specific from the trigonometric coefficient defined x equal to x divided by x plus y plus z, and y equal to y divided by x plus y plus z, and z equal to z divided by x plus y plus z, x plus y plus z equal to 1. So any type of wavelength will come to presentation over to the type of values. Here say the type of information to approximately will come to pointed from the type of value from x, y. The chromatic slides from x and y, red and green. So in this cases, it will come to so many point equal to energy. The chromatic diagrams will come to representation from the type of RGB colors will come to the range of CAE chromatic diagram. See the type of spectral energy locus. So next topic is move to color models. So what is mean by this color model already? The image processing model, we say that two-dimensional come to image processing, casual, non-casual and semi-casual come to say that the type, same time we come to color model to say color space or color system. The facility will come to the specification from coordinate system or subspace within the system. Each color in this model to be represented in the a single point containing the subspace. Such that the most color model will come to say the type of this hardware, the color monitor or printer will say that depends upon this orientation. The color graphics and then RGB model and the color monitors will come to say the type of illustrating from color gamut of color monitor. The triangle and the color printer device will be shadowed region. This is the x-axis and the y-axis. Another one is the CMY, that is a cyan, magenta, yellow, and the CMYK, the cyan, magenta, yellow, and black model, and then HSIQ saturation intensity model. The human to be described from this interpreted color. So HSI model also there's advantages, that is decouples the color and the grayscale information for the particular image. So many of the grayscale technique to be developed in this type of this HSI work only. So the numerous color models usually today to this application and reflection of this color of science. So this is this RGB schematic of the cubic model RGB. This is a basic cuboid. In this say here this is red, this is green, this is blue. The combination of this color, we say this red and blue is combination magenta, and red and green the combination yellow, and you come to blue and green the combination is cyan. So in this middle point of this values is white, and the inverse point will be say this is black. Black and the white in between say is called as a grayscale value. So that is RGB color model. In color spectrum, she'll come to say the spectral components of this red, green, blue. So already we explained this diagrammatic representations of cuboid models. Say this term full color image will come to denoted from 24-bit RGB color image. A total number of possible colors is a 24-bit RGB 2 power 8 power 3, so equal to 16 million 16 billion 777 million of 2016. These figures will come to so many information we come to produce from the type of 24-bit RGB color cube. In this model will come to say this cross section of this RGB color cube and its 3 hidden traits. And the CMY and CMYK color model will be say this at time some type of this RGB, the color monitor RGB, but here say cyan, magenta, yellow, properly will come to 1 minus R, 1 minus G, 1 minus D. So absolutely will come to resultant, that value will come to CMY, cyan, magenta, yellow. And then this model will come to simplified from this. Based on this, black is also be denoted from to combine from, that is a value. So what is the black K equal to minimum of cyan, magenta, yellow, CMY. So there is a conversion to that K to be combined from this minimum of CMY values also be enclosed from CMY model. So simply the fourth color printing will come to representation from K value. So how to this K value to be analyzed from here? C equal to 0, M equal to 0, Y equal to 0, C equal to C minus K divided by 1 minus K, M equal to M minus K divided by 1 minus K, K equal to 1 by Y by K, Y minus K divided by 1 minus K. So in this case of conversion from cyan, magenta, yellow, and then back to CMY to representation from the suppression of this the value of uh, a k value. So c into 1 minus k plus k, m equal to m into y 1 minus k plus k, and y equal to y into 1 minus k plus k. So automatically to reverse of that CMY to be analyzation from the type of this model. So already study about this RGB, CMY and CMYK. Now we'll move to HSI color model. In this color model, we came to screening about this color RGB, CMY and the CMYK model, and changing from one model to another is straightforward. These color systems are ideally suited for this hardware implementation in an addition of RGB system. We'll come to say this RGB and CMY, and what is the primary motivation, hue, saturation, and intensity values. In this say there's a color model, how to say this decouples of the intensity component from pure color RGB. You'll come to say that the type of information from intensity or grayscale value of this image from to be representation from green, red, green and blue. In this say specification from the type of the information among this the particular role of RGB. So each and every time that is a fact will come to say analyzation from this RGB. This is the black, this is white and cyan. That is that case from hue saturation to be HSI color model to plotted from the type of this area. White, black and then cyan. That means we'll say this green, magenta and white or blue will be combination from that area to come to analyze like cyan, white and then black to connected this region. So there is a RGB and HSI to be performing from the intensity of this axis of this value. So in this say everything will come to analyzing 120 degree of secondary colors is 60 degree, primary color is 120 degree. So in this cases hue to be formation from hue and saturation, HSI to be to come to analyzation from the type of this value. So here this is say here cyan out of this hue saturation to be reflection from this area. This is the normal range. This is hue saturation out to be fixing from red. Here red out of link with that is different type of shapes, the hexagonal and triangle and the circle. Whatever any projection of these shapes will come to the red axis will come to pointed from hue and saturations. I means the intensity value. Out of this RGB to convert it to HSI, the simple formula will become to using from RGB H equal to theta 360 degree minus theta degree will come to the based on this B value, B and blue and green, blue is always less than or equal to green, that is a theta, that is a value of rotation, and then B is always greater than G means 360 degree minus theta. If the theta value is the cos inverse of this value, will come to projection from R minus G, that is red minus green, plus red minus blue, and that is divided by that is R minus G whole square plus R minus B into G minus B whole square root. So we come to say the type of this information along with the saturation component will come to is given by this S equal to 1 minus 3 divided by R plus G plus B, minimum of R GB. So in this level you will come to easily to convert it to RGB to HSI color image processing model. So in this way the different shapes of the triangle and circular color plane, it will come to say this white region will come to say intensity level 0.75, 0.5 and I equal to 0.75. We come to say this I equal to 0.5. The value of the converting colors from HSI to RGB. RG sector shall come to say the GB sector, and then type of this BR sector. Depends upon all the value, how to this hue, saturation and intensity levels will come to convert it to the different type of color image processing model. So manipulating from HSI component images will come to say the type of these images, come to RGB and then components of HSI and hue, saturation and the intensity level of these figures will come to easily to known from this is hue, this is saturation, this is intensity values. So that this is this color image model come to present over to the type of a different type of a presentation. So next one, pseudo-color image processing. The pseudo-color sometimes is a false color. That is called false color. The image processing consists of assigning these colors to grade values based on the specific criteria. That time, the terms will come to pseudo or false color is used to differentiate from the process to be assigned this color to achromatic images from this process. So in this case, human pseudocode is for human visualization and interpretation of the grayscale events. So normally intensity slicing of the and the color coding, you come to say this the type of information, 3D functions, or any type of image, pseudo color image processing model. You come to summarize it from 0 to L minus 1, the level of intervals. You will come to say this is a slicing window of this graphical interpretation of this intensity slicing technique, the black and white slicing plane. Here this is say 0 is origin and L minus 1 is the intensity value of level, and that level will come to plane to become to analyzation from what is the false colors to become to project over in your area. So in this alternative come to say this levels of intensity level be starting with this Li and L minus 1 be starting with C1 to C2. So some type of brightness or dull gray in this grayscale image. The varies of regions will come to analyzation from grayscale image. So here this is a grayscale of image of the thicker thyroid phantom. The resultant of intensity sliding from right hand side is equal to 8 colors to be posed with a different type of colors. There is a false color prediction, so pseudo color given from that is the type of saturation will come to say here, that is image will come to say X-ray in an image from a building. The result of color coding process, that is a false color coding that is highlighted from the different type of image in this building part only. So here so many concepts that is false color predictions will come to helpful to analyzing from pseudo color format. Intensity to color transformations also most of the things are for in our satellite pictures analyzation on different type of location of grayscale value. The average monthly that the colors assigned from the intensity values, the color coded to the analyzed from zoom from South African American coding. So here they say this is a transformation from f of xy. What is the main color pseudo color enhanced by this grayscale value of this color. In this case, this is the original picture for Dr. Mike and Harwitz, the Westinghouse. So this is analyzing from the type of pseudo color informations. Pseudo colors to highlight it for explosive in this any type of X-ray images. Especially the medical diagnosis, all the type of X-ray images will be helpful to the pseudo color. False color images will come to more helpful to explosive of this identification of this defects. That is the intensity explosive of the background. The type of the information from color coding, multispectral images. Here they say the type of additional processing. Pseudo color, the coding come to analyzing from a river region. Near infrared components or Landsat of this multispectral image, Washington DC area. Will come to analyzation from that RGB composite image using from IRG model. Infrared will come to band. Will come to based on this the type of RGB composite. Will come to the pseudo color for rendition of a Jupiter moon IO. A close-up for there is a courtesy of this NASA. Say the type of this pseudo color to visually come to analyzation from the type of model. Next, the basic of full color image processing model. Normally, already study about the RGB color image processing model. Same concept. We say this is a type of information how to be representation from arbitrary vector to be a analyzation from this RGB color. So C equal to CR, CG and CB equal to RGB, and then components will come to representation from that as spatial coordinates in this notation. C of x comma y and a representation of this as the type of image will come to analyzation from the type of the pixel notation in 2D neighborhood. This is a grayscale image, this is a color image processing model. In this color image processing model, RGB in the each and every slicing window to combine from single notations. Here a single dot represents representation from single slicing window, but here single dot, the three values should be representation of the single dot, but the three slicing window. So 3D neighborhood, the RGB color image process. The 2D neighborhood is called a grayscale image model. In this model, it come to say so many type of RGB image voxel will come to analyzation from in this work. So next topic will come to analyzation from the type of information noises. I think color transformation is also this one topic will come to analyzation from your work. So most of the transformation, color image transformation, like that, normally transformation means you will come to say one color transformation to another color model. Already, especially RGB to cyan magenta yellow, or cyan magenta yellow to cyan magenta yellow, black K, TMYK, and CMYK to HSI, or color to HSI, RGB to HSI. So many model already we discussed in this previous section. The same that color transformations are more helpful to be analyzation from a different type of information. Here full color image processing model cyan magenta yellow and black. Here cyan magenta yellow and finally red green blue, and the separation from hue, saturation and intensity value. So in this separation from the type of full color will come to play in between the side of this transformation technique. So in this type of RGB and CMYK and CMYI and HSI, so HS model to different type of color complement of this the particular information. So here is RGB and cyan magenta yellow component basic model to reflection over to the type of this complement transformations. A complement transformation, that is this different type of combination of this primary and secondary color. The color slicing, another way of approaches this the color slicing. The slice is the color image to mapping from color outside. So this is the intensity of this each and every range of this value. So slice of this range 0.5 and Ri. There is a range will come to be maybe different from any width slice. So slice will come to say that a different type of color slicing models depends upon this R value or W value. The color slicing transformations value may be different from width adjustment, and may be different from the radius adjustment, and maybe cube and sphere that are replaced from the color values. The tone and the color corrections also be one of the important role from this color full color image processing model. The RGB flat and the character depends upon this light and the character, dark and the character depends upon the tone model itself. And the histogram processing from color images, so like that we change out from the some type of corrections like that original image to another type of image. Histogram equalization, another part of this auto correction of the color space models. So these are this image important thing from image color image transformation techniques. Another concept will move to uh, how to this image noise, color image noise. Say this is another type of technique will come to color noises. How to identification noise? Noise means unwanted things to be present over to this pixel. In how to this color image in this noise. Here say this noise. Color image noise model come to say this charge coupled device. We come to say this so many filtering techniques are there. So unwanted pixels will be removed from this noises in the lower and to higher radiations. We'll come to this say there's noise model RGB image to HSI. The color image averaging from random noise will come to reducing from the type of this information. Sir. The type of HSI you will come to analyzation from that is image noises. Then you will come to noise you will come to be reducing based on so many filtering techniques are there. So I think first unit will come to a finish. Thank you, students.